All right, test number 2 we had in 153. And it says factor completely, fill out this table. And so I've typed the equation in to my calculator. It's a little easier to do this on a Desmos, but I'll do it on the calculator since it's harder for me to show the video of switching back and forth from my calculator or from Desmos to here. So anyway, so I've typed the equation in. Hopefully I've got it right. Checking that, and it's something you should do. 24 minus 9, yes. So if I say graph, this is what it looks like. And it looks like it has a 0 that's not very well defined there. Looks like there's another one there that at minus 1.5. This one's not well defined, but there's one at minus 1.5. I can check that so I can calculate the value at negative 1.5 and it says, yes, it's 0. There's another one in here that I don't recognize, but it looks like it goes up, comes down, and bounces at 1. So I think 1 has a multiplicity 2 because it bounces. And at negative 1.5, it looks like multiplicity 1 because it goes straight through. And then there's another one there just before. Let's see if I can find a spot here where you can see that better. Maybe if I hold it up closer to the camera. There's one here that's a little less than 1, and one way down here at minus 1, 2, 3, 4 something. And those look like they may be not nice decimals, nice fractions. So I'm going to find those by doing synthetic division here with the ones I do have. So I'm going to say my coefficients are 2, 7, negative 14, negative 10, 24, and negative 9. And that's x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, constant. I got all powers of x's going from 5 down. The easier to divide in here of these two is 1, and I'm going to do it twice. So I'm going to do 1, add down, multiply by 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 1, add down, and it went in evenly. So I'm going to do it now for this part once again. I'm going to break it down some more here. And it should go in again according to what I saw on the graph. So I'm going to add down, multiply by 1, add down, multiply by 1, add negative 5 and 11 is positive 6, multiply by 1, negative 15 plus 6 is negative 9, multiply by 1, and I get 0. So 1 went in twice. And for what I saw on the graph, I don't think it's going to go in a third time. But I think negative 1.5 goes in, or negative 3/2. So add down, negative 1.5 times 2, that's 2 plus half of 2 makes it negative 3. Add down, and I get 8. 8 plus half of 8 is 12, and that'll be negative. So I add down, and I get negative 6. Negative times negative is positive. 6 plus half of 6 is 9, and it does go in evenly. So I went from x to the fifth, x to the fourth, x to the third, to x to the second. So I got 2x squared plus 8x minus 6 is what's left. Now, I see that a 2 goes into all these. Now, I could put this right straight into the quadratic formula, and it would not be wrong to find the other two zeros. But if I pull the 2 out, I get x squared plus 4x minus 3. It gives me a little bit simpler quadratic to put into the quadratic formula. Quadratic formula, of course, is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, where a is 1, b is 4, and c is negative 3. So the opposite of b, the opposite of 4 is negative 4 over 2 times 1 is 2, plus or minus the square root, and 4 squared is 16, and negative 4 times a positive 1 times a negative 3 is positive 12 over 2 times 1, it's 2. And so I get negative 4 divided by 2 is negative 2 plus or minus, see, that's 38 square root of 28 divided by 2. Now, if you did simplification of this, it would be nice. 28 is 4 and 7, and the square root of 4 is 2. So 2 would cancel the 2, and this would be minus 2 plus or minus the square root of 7. But you could leave it like this. Or if you'd used these, then you would have got twice as much, 4 times as much in here. 4 times 28, 112, I think, would have been up in the square root, and this would have been over 4, and this would have been 4 out. Still would have been minus 2 out there. But in any case, the other two roots, the exact values are minus 2 plus the square root of 7 and minus 2 minus the square root of 7. Now, the decimal values for these, I think this is minus 4.6 something, and the decimal value for this one was 0.6 something. Those are the ones, if I found those on a calculator, let's see, this one's between minus 5 and minus 4. I can find those by going second, calculate the 0. That's between minus 5, enter, and minus 4, enter. My guess is minus 4.5. Then it says no, make it a 4.645, and really close to 0. E to the minus 11 is really close to 0. So this is once, and this is once, and it goes straight through on this one. And so now I'm ready to write the factored form. Now, I see that f of x has a 2, and we've pulled out the 2 here, or we would have had a 2 in front of this, but there's a 2 if I write it in factored form with single x's, as I shall do here. X, if it's minus 1.5, it's x plus 1.5, because negative 1.5 plus 1.5 is 0. If it's 1, it's x minus 1, because 1 minus 1 is 0. And this one happens twice, because it bounced there. And then we have these two. So if I got this, and what I add to that to get 0 would be a plus 2 and a minus square root of 7. So if I put this in for x and added this to it, I get 0. That's why this is always opposite in sign to this. And if I put this in for x, I would have to add 2 and add square root of 7 to make that be 0. Now, if you use the decimal ones, it would have been x, since it's at 0.06 something, I would have x minus 0.6 something, whatever that decimal is. And if I had this one, I would have had x. This is a minus 4.6, so I had plus 4.6, blah, blah, blah. So if I factored in using the decimals, it would look like this. If I factored using the exact values, which gave me bonus points, I would have had it like that. Okay, y-intercept. Well, y-intercepts means you put in 0 for x. If I put 0 for all these x's, I get -9. X-intercepts, well, that's pretty clearly -1.5 would give me 0. 1 gets me 0. -2 plus the square root of 7 gets me 0, or 0.6 something, 0. And intercepts are points. That's why I'm giving these ordered pairs points. And -2 minus the square root of 7 would give me 0. And the in behavior, well, this is a 5th degree, so once their ends are going to go opposite. One side's going to go up and the other side's going to go down. And since this is positive, the negative side will be down and the positive side will be going up as you go far to the left or to the right. That's what I mean by in behavior, and that's what scientists and mathematicians want to think about as in behavior. What does it happen going that way? Local maximums. Well, if this really does this and it's got degree 5, it could have as many as 4 turns. Well, we saw in the graph that it must have been going up, coming down, then going back up, and have a max there, little bump, and then goes back up. So there must be a maximum up here somewhere and a maximum right there. So to find those, I go on the calculator, I go second, calculate the maximum. That's somewhere between -5 and 0. -5, enter, 0, enter, and it says make a guess. And I'm going to say, well, maybe -3. And it says, no, -3.7 is where it happens, but the maximum is 399.84. That's basically 400. That's one maximum. Now I'm going to write down where it's at just for something later. This happens at x equal -3.735, but I don't need that. That's the maximum. And there's another one here, somewhere between 0 and 1. Second, calculate the max. Between 0, enter, 1, enter. And it looks like at 0.6 we think it is, and it says no, it's at 0.76. That's where it's at. 0.7697, about 77, rounded off. But the maximum is, this is the number I need for this, because the maximum is how high it got to, and it got to 0.16 something. Okay? Now, minimums. Well, this went up, came down, and so there's a minimum in here, and there's a pretty obvious one there. It hit 0, right? Get that out of the way. It's 0 right there. So one of the minimums is 0, and it happened at x equal 1. But the other one is way down here somewhere between, -1 and 0, probably. So I'm going to go second, calculate a minimum that's between 0 and 1, and I'm going to go 0.5, and it says, nope, 0.76. It's at x equal 0.769, whatever, basically 7.7, but the value is, this is what I need. Nope, that's maximum. What am I doing here? Between -1 and 0, I'm trying to find a minimum. Second, calculate the minimum between -1 and 0, enter, and -0.5, and it says, got the wrong thing. I was at the wrong place. It's -0.83 is where it happens, -0.83-ish, and the minimum is -25.27-ish. So there are 2 minimums in this problem and 2 maximums in this problem. Now it says, when is this graph, one of the y values, less than or equal to 0? So I don't need to talk about the y values. I need to say for what x's are the y values less than 0. Well, this graph is coming up and then goes really high and comes down. So it's positive for all this piece, but it's negative. All this part, the y values are negative up till there. So from -infinity up until it reaches 0 here, which was, if we remember back, -4.6 something. From all the way down here up to there, the y values are negative. And then equal to 0 at that 4.6 whatever. So this was actually -2 minus the square root of 7 if I want the exact value. Union, the next place it's negative. So it went positive, came back down, so it's negative from -1.5. It's 0 at -1.5, so and it says keep it 0, so I don't use a parentheses. I want the -1.5, it's 0, and then it's negative clear up until this 0.6 something. 0.64, whatever it was, and we want it when it equals 0. Now this was actually the -2 plus the square root of 7 is the exact value there. And so it was negative for all the x's between here and there. Then it was positive for just a short bit, and then it was 0 only at 1. So that's another place where it's equal to 0. So we have to go union from 1 to 1. It was also 0. Yeah, this is no width on that interval. It's just 1. So that's the intervals where this y values are less than or are equal to 0. And now we got to figure out when it was decreasing. Well, increasing and decreasing depends on which way you read it. Well, we're supposed to read it left to right like you read a book. And so as you're going this way, the graph is getting higher and higher and higher. So it's increasing until it reaches that maximum. Now, we don't want to know the y values. We just want to know when, and when we say when, for what x values is this graph going up? Well, it was going up all the way up to negative 3.7, our maximum. Then it decreased, and that's where we want. So and that's why I wrote these down here so I could have it for this part. From negative 3.735-ish, and we never include the maximum because it's changing there. It was decreasing after that peak till it got to the minimum, and the minimum here happened there. And so we're looking at the x values when we're answering these questions. So it decreased from x at negative 3.735-ish to negative 0.83-ish. It decreased. Then it increased, and then it had a short decrease in here for a little while, and so we got to get that. So it was 0 at, going back there, 0.6 something. This was minus 2 plus the square root of 7. This was nope, that wasn't that one either. It decreased from the max to the bottom. Oh, we don't want to go from there. That's the 0. Oop. We want to go from where it was the very highest, which was at 0.77, 0.77-ish. And we'll learn how to get the exact values in calculus. And then it went down until we got to 0, or to 1 in x, where the height was 0, but 1. And then it went back to increasing. So there's the intervals of decreasing. That was page 1, and that took quite a bit of time. That was the big, heavy-duty problem. Page 2. So if a punter is going to kick the ball into the air for 4.2 seconds, then it's going to be on the ground or near the ground when they kick it at time t equals 0, and it's going to go up and then come back down at 4.2 seconds. So to have a parabola that goes that way, it's going to be t, that would make it 0, t minus 0, 0, and then t minus 4.2. Now, to be an upside down, it's going to have a negative, and to be affected by gravity, and we're talking feet, we use half of the acceleration of gravity, which is 32, so we use negative 16. And that's the equation for the height. So if I put that into my calculator, determine the height and feet that would have to be kicked to. So where's the highest it gets to? Well, we can just graph that. And in Desmos, you can tap on the top and it'll tell you at what time it's at the highest and the highest. I could do the same thing on the calculator, or I could put in, if it's a parabola is very symmetric, so if it's at a height 0 at 0, at time 0, and it's a height 0 at 4.2, halfway between, it's at the top. So I can put 2.1 in here, so I go negative 16 times 2.1, 2.1 minus 4.2, which is minus 2.1. So I'm going to get negative 16 times 2.1 squared squared, and one of those was negative, so the actual answer is positive. 70.56 feet. That's how high it would have to get. The average velocity between 1.2 and 1.3, velocity is in like miles per hour or feet per second or something like this. And since we're doing feet, we're going to figure out the change in the height in feet. So we're going to figure out how high it was at 1.3 minus how high it was at 1.2. So we're going to put 1.3 in for the t's and 1.2 and figure out how high it was at the end versus how high it was beginning over the change in time. Change in the distance over the change in the time is average velocity. And the time went from 1.2 to 1.3, so I do 1.3 minus 1.2. End time minus beginning time to find the change in time. So I'm going to go to y equals, I'm going to turn this one off and go down and type in my equation, negative 16 x parenthesis x minus 4.2, close parenthesis, and if I have my calculator in independent variable ask, I can go to the table and I can type in 1.2 and 1.3. I can just type them in here. I can type anything I want in here. One of the things we needed to find was at 2.1, and there's the 70.56 that we had here. So we want the difference between 1.2 to 1.3, so we take 60.32 minus 57.6. 60.32 minus 57.6 over 1.3 minus 1.2, and 60.32 minus 57.6 is that, and I got to divide that by 1.3 minus 1.2, and it's 27.2. 27.2. This was the height, which is measured in feet, and this was the time measured in seconds. So it's 27.2 feet per second. And now the average velocity just before it hits the ground at 4.2. So we can do it between the height at 4.2 minus the height at really close to there. We can do 4.1 is going to be pretty good. We could do 4.19. We could do whatever we want. And then I have to do 4.2 minus 4.1 or whatever we used to get that. And we get an average, average speed near the end of, let's see, table, there's 4.1, 4.2. So 4.2 minus that is minus 6.56. 0 minus 6.56 is minus 6.56. 4.2 minus 4.1 is 0.1. And 0.1 divided into there makes negative 65.6. And this is again in feet and seconds. Complete the square. So we're trying to change this to the transformational form. So we factor 4 out of the x terms. So this becomes 4. X squared plus 4x, because 4 times x squared is 4x squared, 4 times 4x is 16x. Then we go plus something, minus something, close the parenthesis, leave the minus 2 outside. Forget about it for a little bit. We want to make these three be a perfect square. So it's got to be x plus half of 4, which is 2. If I multiplied this out, I'd get x squared, I'd get 2x, and 2x is the 4x, and I get 2 times 2, which is 4. That number squared. Well, I just added this to the equation. I can't do that and not compensate for that, so I have to take it away right away. Now, these three terms is what this is. 4 is times all this, so 4 is times all of that. But this is also in the parentheses, so I got to take 4 times the negative 4, which is negative 16, and the negative 2 is negative 18. So my function in transformational form looks like this, which says it's moved minus 2 and down 18, so that's where the vertex is. And the axis of symmetry is the center line, and since this is a parabola that's moved minus 2, the center line is going to be right at x equal minus 2. Center line, vertex. The minus 18 is only involved in here. This says it was moved minus 2, and so that's why the center line is x equal minus 2. And I think I got just enough time to do this one, and then I have to go to class. So I'm going to put x here, and I'm going to call this y. Now, if I'm going to build these pens, I'm going to have x length of fence 1, 2, 3, 4, 5, 6 times. So I'm going to need 6 lengths x, and then I'm going to need the y length twice, plus 2y would be all of my fencing, which is 500 feet. Now the area of this is going to be x times y, and so I'm going to try to get the y out by solving for y. So I'm going to subtract 6x from both sides, so I get 2y equals 500 minus 6x, and then I'm going to divide by 2, and so I'm going to get y. I'm going to have my x, and my y is going to be 500 divided by 2, 250, and negative 6x divided by 2 is minus 3x. And if I multiply this out, I've got 250x minus 3x squared. It's a parabola that's upside down, and I want to find the maximum because they want me to maximize the area. Well, there's my b, and there's my a. It's going to happen at minus b over 2 times a, which is 41 and 0.666666, or 41 2/3, I believe. Let's just check and make sure I'm doing that right. So 250, they're both negative, so it's going to come a positive divided by 6. Yes. So this would be x. So each one of these is 41 2/3 feet. And to get the y, I can take 6 times that and subtract it from 500. So I'm going to take that answer times 6, and I get 250 feet. So I'm going to use 250 feet, or half of my fencing for those. So the other half would be for the 2y's. So the 2y, this is 250, subtracted from the 500, I get 250 divided by 2, and y has to be half of 250, which is 125 feet. So the whole length is 125 feet, or just one pen. If I want the dimensions of just one pen, it would be 41 2/3 feet, and 125 divided by 5 is 25 feet. Now, if you'd made y be here, you would have gotten 25 for y instead of 125 for all of them. Okay? That's half of it. I'll do the other ones later today.